Okay, so we are into IC method. So let us solve one more problem on IC method. So problem number 4. So let me first draw the figure. Okay, so now you can see that this is the mechanism that is given. Some of the dimensions we have to write still. So AB is 28. BC 75. FS is not required because you can, from E you can cut ES, so you get this point. Okay, so this is the data, and then we are asked to find omega 3, omega 4, omega 5. So we are asked to find out these many things, and this is the mechanism that is given. So with this much data, it is possible for you to draw the linkage diagram. So up to this you can easily draw. Now let's see how do we move further. We want to solve it by IC method. So we need to know the ICs. So whichever ICs are available by observation, those ICs we will mark first. So this is O12. Now this is O23. This is 3 with 4, so O34, 4 with 1, so this is O14, 3 is connected to 5, so this is O35, 5 is connected to 6, so this is O56, and here 6 is connected to 1, so this is O16. So these many ICs we already know. Now let's go further ahead and start the work from link number 2. So considering the link number 2, because omega 2 is given, that's why we start with link number 2. So first we write velocity of O23 V equal to omega into R. So 1, 2 to 2, 3 distance is known, omega 2 is given. So we know this velocity, and it is perpendicular like this. You can show this in the figure and write the name. Now 2, 3 belongs to link number 3 also. So for link 3, we write the same point, velocity of same point with respect to 3, so it is O13 to O23 into omega 3. So this is velocity of 23, which is already found out earlier. Now that is going to be equal to omega 3 and the distance. Now right now distance is not known, omega 3 is also not known. So if you could find out the distance, then you can find out omega 3. So now our job is to find out where is O13. So now we come to Kennedy's circle. Okay, so whatever centers we know, those lines we join. So 1, 2 is there, 2, 3 is there, 3, 4 is there, 1, 4 is also there. Then there is 5, 6, there is 3, 5, there is 1, 6. These centers are known. 1, 2, 3, 4, 5, 6. 7. Okay, now for finding out O13, so let's join 1 3. Now for 1 3, what do we write? 1 2 and 1 3. 1 2 and 2 3 are. Then O14 and O34. So let's do this. Now we'll do this 1 2 and 2 3. So 1 2 and 2 3, this line. 1 2 and 2 3. The other line is 1 4 and 3 4 in this line. So that is the intersection, which is the point O13. So we obtained this O13 there. And now the distance from O13 to O23, this much distance is known. So this link number 3 is rotating about this point. One point on link number 3 goes like this. Therefore, omega 3 is going to be like this, which is clockwise. So now we write here, distance is known, omega 3 you have to find out, omega velocity is known. So you can find out. And it is clockwise. So we got the answer of omega 3. How much is omega 3? Now any other point on this link number 3 you can find out the velocity. So we can now find out velocity of 3 4 and velocity of 3 5. So we write immediately, we are still in link number 3. So we write velocity of 3 4 is equal to omega 3, distance from 1 3 to 3 4. And you get this. Similarly, velocity of O35. So omega is known, distance is known, omega is known, distance is known. You can get the answers of velocity of 3 5 and velocity of 3 4. It will be perpendicular to the line joining these two. So if you do that, see this you have to show in your linkage diagram by drawing such kind of very medium kind of lines. These lines should not be dark, otherwise you will not be able to identify where is the linkage. So the linkage diagram must be dark, darkest of all, and other things should be drawn as a medium lines. So this will be velocity of 3 5 and this will be velocity of 3 4 3 5. Velocity of 3 5, velocity of 3 4. So we have got this much. Now let's go to link number 4. So for link number 4, we write down velocity of O34, which is already known here. We already know this, equal to omega 4, distance from 1 4 to 3 4. Distance from 1 4 to 3 4. Now since velocity is known and the distance is known, 1 4 to 3 4 is known, we can find out omega 4. So we can find omega 4 right here. And it will be in the clockwise direction. It will be in the clockwise direction for link 4. Now let us go to link number 5 and write the similar equation there. So just I'll make some space here, write this down. Okay, so now consider link number 5. So for link number 5 we write velocity of 0.35 is equal to omega 5, distance from 1 5 to 3 5. Usual equation we are done, and 3 5 is the point on link number 5. So omega 5 into distance from 1 5 to 3 5. Why 1 5? Because 1 is fixed link and 5 is the link which we are talking about. So we have written the equation. Out of that, velocity we already know earlier, and the distance, if you know 1 phi, then you can measure a distance from 1 phi to 3 phi. So this distance will be known, and then you can find out omega phi that is asked. So let us now make an attempt to find out O1 phi where it is. 1 and phi is not yet found out, so we will join 1 and phi and try to find out 1 phi. So how do we find out 1 phi? 1, 3 and 3 phi. 1, 3 and 3 phi. The other is 1, 6 and phi 6. 1, 6 and phi 6. So let us join these two, 1, 3 and 3 phi. So 1, 3 is here, 3 phi is here. So this line is 1, 3, 3 phi. The other line is 1, 6 and phi 6. So phi 6 is here and 1, 6 is here. So this line. So one line is this, other line is this. So they are already there. So you can now say that the intersection here is 0.015. One line like this, other line like this. So this is 0.015. So we have obtained now 015, and because we have obtained 015, now you can find out omega phi. So what it means is, this ring number phi is rotating about this point, and one of the points is going like this. Therefore, you say that ring number phi is rotating about this point like this, which is clockwise. So we write here clockwise. So velocity of link number 5, angular velocity is going to be clockwise. Now we know angular velocity of link phi. So any other point on link phi you can find out its velocity. So phi 6 now you can try. So we write now velocity of O phi 6. Phi 6 just like 3 phi, phi 6 is also on link number 5. So we write this is equal to omega phi, distance from 1 phi to phi 6. So 1 phi to phi 6 is this distance. So this distance into omega, so that will give you velocity of phi 6, which is like this, perpendicular to this line. So phi 6 is going like this. So you will find here omega phi is known, this is known, so you can find out velocity of phi 6. So you got the velocity of phi 6. Now phi 6 is a part on link number 6. 5 also and 6 also. By the way, we have found out omega phi. So now let's go to link 6. So for link number 6, what do we write? Any point on link number 6, O phi 6. So velocity of phi 6, if it is on 6, then it will be equal to omega 6, distance from 1, 6 to phi 6. Omega 6, distance from 1, 6 to phi 6. So what is known? Phi 6 velocity is known. Distance from 1, 6 to phi 6 is this distance is also known. So you can find out omega 6. So find this is the angular velocity of link number 6. So one point on link number 6 is going like this, and this is the rotation point. Therefore, omega 6 will be like this. So that is anti-clockwise. So we write here, this is anti-clockwise. Angular velocity of 6 is going to be anti-clockwise, and the magnitude is this much. So we have found out the angular velocity of 6. Now what is remaining is velocity of g. So how do you find out velocity of g? G is a point on link number 6. So we are already in link number 6. So we write here velocity of g is equal to omega 6, distance from O16 to g. Distance from O16 to g, this distance is fg. Fg is already there. So distance we know, omega 6 we have just now found out. So you can easily find out what is the velocity of g. Velocity of g is omega into r, and it will be in which direction? Since it is going like this, you can say that velocity of g. So this velocity of g is this. Answer is this. So we got the answers of all the various things that are asked. So you'll get some idea how we have solved the problems. How are we solving the problems? By making use of the ICs. So instantaneous center method, for finding out the instantaneous center, we observe and find out some of them, and those which are not found out just by observation, they are obtained by making use of Kennedy's principle. Kennedy's circle is drawn, and from that we find out the other centers, and those centers we use for finding out the velocities. The basic formula still remains the same. V is equal to r into omega, and what we find is, we find out the velocities and angular velocities one by one, and according to that we get the all the different answers that are asked. Okay, so try to understand this problem very well, then you will be able to solve such problems on your own.